Hi everyone. Today we're going to talk about question 10 of the June 2025 Earth and Space Science Regents exam. So let's get started. As always, underline or highlight any unknown words, word meanings, context clues, important details, relationships between things, and circle any task verbs for answering the question. So it says computer-based global climate models. I'm underlining or highlighting models because we've seen this a couple times before, are helpful tools for collecting data on projected future climate conditions. This might be an unfamiliar word overall, so I'm highlighting that. These models use various scenarios or possibilities that assume different human based decisions on how we address greenhouse gas emissions. I'm underlining or highlighting scenarios and possibilities because it seems that possibilities is the word meaning for scenario here. And these scenarios or possibilities assume different human based decisions on how we address greenhouse gas emissions. So, context clues, I'm highlighting that. So, if I'm just reading the highlights, I see that the models that these global climate scientists are talking about or looking at show projected future climate conditions, meaning future climate conditions that they think may be possible, such as scenarios. And these models have different scenarios or possibilities. And I see over here that can be scenario A, B, C, and D. And these possibilities assume different human based decisions on how we address greenhouse gas emissions. So each possibility or each scenario is showing me a different human based decision on how we're dealing with these greenhouse gas emissions. The graph below, I'm highlighting graph because it's talking about this now, shows future greenhouse gas concentrations for 4 different greenhouse gas emission scenarios. So once again, it's giving me 4 different scenarios or possibilities, and for future greenhouse gas concentrations. So what might be the concentrations in different scenarios of greenhouse gases? And it says measured in parts per million ppm. So I see ppm right here, or parts per million. It says CO2 equivalent. I know that this just means greenhouse gas emissions that are measured by in parts per million. So how much greenhouse gas is being emitted in 4 different scenarios or possibilities in which humans are making decisions about greenhouse gas emissions. Okay. All right. Then moving on, I see another graph. The graph below shows some information about global surface air temperature changes. So, this graph is talking about global surface air temperature changes. I'm highlighting that. And these models are compared to the average global surface air temperature between the year 1986 to 2005, indicated at 0 degrees Celsius. So, all these models that we were talking about are compared to the average global surface air temperature. So, overall, the average air temperature of the surface between 1986 to 2005. I'm going to highlight those areas. It seems 1986 is right here, 2005 is right here, indicated as 0 degrees. This is 0 degrees Celsius right here. So I'm seeing that this area right here that merges 0 degrees Celsius and between 1986 and 2005, it's talking about right here. So we're comparing these models A, B, and C to what the average air temperature was around here in this time. Okay. So number 10, identify. I'm going to circle any verbs that are given to me to do something. The numerical values, I'm highlighting that. So it wants a number. Numerical value means number for the projected concentration of greenhouse gases, CO2 equivalent. So now I know that the CO2 equivalent that I saw here means the projected concentration of greenhouse gases. So I need a number, the numerical value from here. So identify the numerical values for the projected concentration of greenhouse gases, CO2 equivalent, and for the approximate future change to global surface temperature. So I need a future change, highlighting that to global surface temperature. That's this graph right here. Global surface temperature for the year 2100 using scenario B emissions. So specific details that I need the concentration of greenhouse gases, CO2 equivalent from this graph right here, and I also need the future change to global surface temperature from this graph, and I need both of those for the year 2100, and I'm only looking at scenario B emissions. Okay. So first, let's find the projected CO2 equivalent in the year 2100 in parts per million. So I'm going to come over here. I know it's talking about CO2 equivalent in parts per million, Then I see in scenario B for 2000, the year 2100, the concentration was around 800 parts per million. So if you put any value from 795 to 805, that will be correct over here, as it wants a numerical value. Next, we want the projected global surface temperature change for the same year and for the same scenario. And for this, I'm going to go to this graph right here. I see in the year 2100 for scenario B, the temperature was somewhere over here, which is somewhere around 2.4. So if you put any value that would round to 2.4, that would be correct over here. And that's it. In the next video, we're going to talk about question 11. Thank you.